Today we're going to talk about composition of functions. Specifically, we're going to talk about adding, subtracting, multiplying, and dividing functions. Before we begin, we want to go over some notation. So if you remember last week we talked about f of x representing function notation. Today we're going to expand on that a little bit because we have f plus g of x, and we have f minus g of x, f times g of x, and f divided by g of x. Okay, so another way of saying f plus g of x is to say f of x plus g of x. So we want to make sure we know the notation and what it looks like and how to say it so that we sound educated when we use it. So here we would have f of x times g of x, and that's the same thing as having f times g of x. Okay, so now that we know what this stuff looks like, let's talk about how to use it. So if you remember Friday, we talked about how to add and subtract polynomials, and one of the reasons we did that was because we wanted to be able to combine functions today. So if you notice, we have f plus g of x, and up here at the top we know what f of x is, and we know what g of x is. Essentially, all they're asking you is the same thing that they asked you on Friday when it said add this polynomial to this polynomial. But instead of saying we have this polynomial plus this polynomial, they said it as f plus g. So what you need to do is you need to take it and rewrite it like we looked at it last week so that you know what to do. So we're going to take our first polynomial and we're going to write it. 5x squared minus 2x plus 3. Since it's plus, I don't have to distribute my minus sign if you recall the steps. I'm going to take my second polynomial, write it underneath my first one, matching up the exponents. So that's going to be 4x squared plus 7x and minus 5. Again, just like last week, if you had exponents that didn't match up, you would either leave a space underneath it or you would come out here to the front and you would write it in front. Now we're just going to add 5 plus 4, 9x squared. Remember, when you add, you do not change the exponents. Negative 2 plus 7, 5x, and 3 plus negative 5, negative 2. Final answer. Same thing you did on Friday, it just looks different from the original problem. Let's see what subtraction looks like. So here they have f minus g of x. Remember, they could also write that as f of x minus g of x, and that would be asking you to do the same thing. So we're going to do our steps from yesterday. We're going to take, from Friday. We're going to take our first polynomial and write it. F of x, 5x squared minus 2x plus 3. It's minus g, so what I need to do is come over here to my g polynomial and I need to change all of the signs because it was minus. So that's going to be negative, negative, and positive 5. So then I match up the exponents. I've got negative 4x squared, I've got negative 7x, and now I have positive 5. Remember to add the polynomials together. 5 plus negative 4 is 1x squared. Negative 2 plus negative 7 is negative 9x, and 3 plus 5 is 8. Please don't forget to write your polynomial in standard form with highest exponent first if it's not already written in standard form. So addition and subtraction of functions is the same thing as addition and subtraction of polynomials that we learned on Friday. So we shouldn't have any trouble with this based on what I've seen from the work that you turned in. Next, we're going to talk about multiplication and division. So here we have f times g of x, which again is the same thing as f of x times g of x. And if you remember, we talked about this on Thursday, I believe it was, when we used FOIL, or we used the distributive property. Those are what we're going to be using here when we're multiplying. So if we have a binomial, which is 2 terms, times another binomial, which is 2 terms, then we would use FOIL, first, outer, inner, last. If we don't have a binomial times a binomial, then we're going to use the distributive property. And if you remember, the distributive property says that I take all of the numbers from the first one and multiply it times all of the numbers from the second one. So let's look at our example here. We've got 5x to the second, f of x, times 3x plus 1, g of x. So just come down here and write it as a multiplication problem. We've got 5x squared times 3x minus 1. So I noticed that it's not a binomial times a binomial, so I'm not going to use FOIL. I'm going to have to use distributive property. And the distributive property says I take the numbers here and I multiply it times all of the numbers on the inside. So 5x squared times 3x gives me 15x to the third. Remember, when you multiply, you have to add the exponents. 2 plus 1, x to the third. Then we've got 5x squared times negative 1, which is negative 5x to the second. Multiply. Using the distributive property, or sometimes you'll have to use FOIL. Division. So we've got f divided by g of x. So we're going to divide these polynomials. So what we're going to do is we're going to take f, we're going to write it on top as the numerator. Take g, write it on the bottom as the denominator. So f of x is 5x squared divided by 3x minus 1. Now, we're not going to talk about or get into dividing the polynomials yet. That comes later in the class. Right now, we're just going to set up the problem. So this is all you have to do, is set up the problem. You're not actually going to divide. So do not try to divide these because we haven't gotten into that yet. What you do need to do, however, is you notice we have 3x minus 1 in the denominator of the fraction. Hopefully you know that you cannot have 0 as one of your denominators. You can't divide any numbers by 0. It doesn't exist. So what we have to do is we have to take this part of the denominator, we have to come over here to the side, and we have to say 3x minus 1 equals 0. And what we need to do is we need to solve this to find out what number will make the denominator equal 0. Okay, so I'm going to add 1 to both sides. 3x equals 1. Divide both sides by 3. X equals 1 over 3. So if x equals 1 over 3, then the denominator of the fraction will equal 0, and we can't have that. So what you have to do is you have to take the fraction that you wrote, your division problem, 5x squared divided by 3x minus 1. And then next to it, you have to write x does not equal 1 over 3. Okay? Because x cannot equal 1 over 3 because it will make my denominator 0, which means my problem won't work. So we're not going to divide the fractions, but what we do have to do is take the denominator, set it equal to 0, and solve it so that we know what the denominator is. Alright, let's do one more example of multiplication and division because I think that's where you might struggle a little bit. So let's say f of x equals 2x minus 3 and g of x equals 4x plus 1. So, what is f of x times g of x? So we're going to write a problem. F of x, 2x minus 3, times g of x, 4x plus 1. If you notice, this time we have a binomial, 2 terms, times another binomial, 2 terms. So we're going to have to use FOIL. So FOIL says I take the first numbers and multiply them together. 2x times 4x, 8x squared. Then it says I take the outer terms together. So that's the outside. 2x times 1 is 2x. Then I take the inner terms. So negative 3 and 4x makes negative 12x. Then you take the last terms. Negative 3 times negative 1, negative 3. When you use FOIL, these numbers here in the middle should be like terms, so you're going to want to combine them. So 8x squared. 2x minus 12x is negative 10x, and then minus 3. This right here is going to be my final answer of f of x times g of x using FOIL. Remember, you can also use the distributive property. It's the same process. 2x times 4x, 2x times 1, negative 3 times 4x, negative 3 times 1. Same exact process. But FOIL only works for binomial times a binomial. Now let's do division. Let's use the same problem, except this time, let's find out what is f of x divided by g of x. So let's use division with these same 2 functions. F of x divided by g of x. What does that equal? So we said we take f of x, make it the numerator, g of x, make it the denominator. So we're going to have 2x minus 3 divided by 4x plus 1. We're not going to try to divide any of these numbers. What we are going to do, however, remember, is take the denominator and set it equal to 0. 4x plus 1 equals 0. Remember, we're doing this because the denominator of my problem cannot equal 0 because you can't divide by 0. So we have to find out where that happens at. Subtract 1 from both sides. 4x equals negative 1. divide both sides by 4, and we find that x equals negative 1 over 4. So when x equals negative 1 over 4, the denominator of my fraction would be 0, and we can't have that. So my final answer then is going to be 2x minus 3 divided by 4x plus 1. And then we take what we just found here, x equals negative 1 over 4, and we say x cannot equal negative 1 over 4 because that would make the denominator equal 0. The back of your notes has some stuff on composition functions, and we'll talk about that tomorrow. We're not going to get into composition today. So today you're going to practice adding, subtracting, multiplying, and dividing functions.